Sequences can be given by an explicit formula, or they can be defined recursively. That is, a sub n is expressed in terms of previous elements. If we are given a recursive sequence, we may be able to find an explicit formula for the sequence. The technique is to write out several terms and look for a pattern. In this example, we want to find an explicit formula for the recursively defined sequence a sub 1 equals 1, a sub n equals 1 half times a sub n minus 1 minus 1 for n greater than or equal to 2. We need to find a pattern, so we'll write out a few terms first. Start with n equals 2. We already know a sub 1 equals 1, so we can use this to find a sub 2. We have a sub 2 equals 1 half times 1 minus 1, which equals negative 1 half. Now let's find the third term in the sequence. This time we'll use a sub 2 to do this. This gives us a sub 3 equals 1 half times negative 1 half minus 1, which equals negative 5 fourths. We can repeat this process again to find a sub 4 to get a sub 4 equals 1 half times negative 5 fourths minus 1 equals negative 13 eighths. Now we need to look for a pattern. The denominator for each n is negative 1 over 2 to the n minus 1. We can check this by verifying that 2 equals 2 to the power 2 minus 1, which it does. The same holds true for 4, which is equal to 2 raised to the power 3 minus 1, and so on. The numerator for each n is 2 to the n minus 3. Again, we can verify this by setting each numerator equal to 2 to the n minus 3 and substituting in the corresponding value of n. Putting this together and simplifying, we have negative 2 to the n minus 3 over 2 raised to the n minus 1 power equals 3 over 2 to the n minus 1 power minus 2. Therefore, the explicit formula is a sub n equals 3 over 2 to the n minus 1 minus 2 for n greater than or equal to 1.